Good morning. Today's lesson, lesson 4.7, on page 165 of your third grade Go Math book, is patterns on the multiplication table. And our essential question is, how can you use properties to explain patterns on the multiplication table? All right, so unlock the problem. You can use a multiplication table to explore number patterns. And in this activity, materials say a math board that you can just use a piece of paper, an extra piece of paper for this. Write the products for the green squares. What do you notice about the products? Okay, so remember that multiplication table works that the blue column or the blue rows times the yellow columns will give you the products. So they want us to do the green box. So it's 8 times 0. 8 times 0, 0. Then the next one is 7 times 1. 6 times 2. 5 times 3. 4 times 4. 3 times 5. 2 times 6. 1 times 7. 0 times 8. Okay. What do you notice about the products? Well, I see 2 zeros. I see 2 sevens. I see 2 12s. I see 2 15s, and then a 16. I have 4 on this side. I have 4 on this side. So some of the products are the same. And I noticed that as I was going up the row, that it was 0, 7, 12, 15, and then the other side it went 15, 12, 7, 0. So the products switched orders. Write the multiplication sentences for the products on your math board. So this is where you might need an extra piece of paper because they want us to notice something about the factors. So I'm just going to try to write mine on here. And so I'm going to start 8 times 0. Equals 0. 7 times 1 equals 7. 6 times 2 equals 12. 5 times 3 equals 15. 4 times 4 equals 16. 3 times 5 equals 15. 2 times 6 equals 12. 1 times 7 equals 7. And 0 times 8 equals 0. What do you notice about the factors? So we have 8 times 0 and 0 times 8. We have 7 times 1 and 1 times 7. We have 6 times 2 and 2 times 6. We have 5 times 3 and 3 times 5. And in the middle we have 4 times 4. So these are factors in opposite order. So they have the same factors, but they are in a different order. Will this be true of the yellow square? Explain using a property you know. Well, let's go ahead and look at the yellows. I'm going to assume that this is going to be true because the numbers in the factors are the same on both sides. So once you reach the middle, it should change because of the commutative property of multiplication. So let's just see. 6 times 0, 0. 5 times 1, 5. 4 times 2, 8. 3 times 3, 9. 2 times 4, 8. 1 times 5, 5. And 0 times 6, 0. So I do see the same pattern. Okay, so yeah, this is the commutative property of multiplication, where we have the same factors but in opposite order. This first one we had 6 times 0, and on the other side it's 0 times 6. They just switched. All right, complete the columns for 1, 5, and 6. Okay, 1, 5, and 6. So 1 times 0, 0. 1 times 1, 1. 1 times 2, 2. 1 times 3, 3. 1 times 4, 4. 1 times 5 we have. 1 times 6, 6. 1 times 7 we have. 1 times 8, 8. 1 times 9, 9. And 1 times 10, 10. So then we're going to do the same thing for 5s and 6s. 5 times 0. 5 times 1 we have. 5 times 2, 10. 5 times 3 we have. 5 times 4, 20. 5 times 5, 25. 5 times 6, 30. 5 times 7, 35. And at this point, we're just counting by 5. So we could just keep adding by 5s and finish the row. But I do want to continue to practice saying the multiplication problems. 5 times 8, 40. 5 times 9, 45. 5 times 10, 50. Okay, now let's move over to the 6s. 6 times 0, 0. 6 times 1, 6. 6 times 2 is 12. We have that. 6 times 3, 18. 6 times 4, 24. So we should recognize that we're counting by 6s. These are multiples of 6 because 6 is a factor. So products of problems that have a 6 as a factor are multiples of 6. 6 times 5 is 30. 6 times 6, 36. 6 times 7, 42. 6 times 8, 48. 6 times 9, 54. 6 times 10, 60. All right, so we've written the products for 1, 5, and 6, and it says now look across each row and compare the products. What do we notice? So 0, 0, 0, 1, 5, 6, 2, 10, 12, 3, 15, 18, 4, 16, 20. So I think what I'm noticing is that if I add the product for 1s plus the product for 5, I get the product for 6. So 5 plus 25 is 30. 6 plus 30 is 36. Okay, so if I had to explain that in terms, I would say the sum of the products for columns 1 and 5 equal the product for the column for 6. And that's an example of distributive property. Explain how you can use these patterns to find other products. Well, what if we did the row of 1 plus the row of 6? 0, 0, we get 7. 1 plus 6, we get 7. 2 plus 12, 14. 3 plus 18, 21. 4 plus 24, 28. So we were looking at this math talk question. It says, how can you use these patterns to find other products? And if I add the products for 1 and 6, I could get the product for 7. So if we continued it, we get 5 plus 30, 35. 6 plus 36 gives us 42. 7 plus 42 gives us 49. 8 plus 8, 48, 56. 9 plus 54, 63. And 10 plus 60, 70. Okay, let's move on to 166. All right, shade the rows for 0, 2, 4, 6, and 8, and 10 yellow. I'm going to pause for a second while I grab those materials. All right, so let's continue. And it says shade the rows for 0, 2, 4, 6, 8, and 10 yellow. All right. So just go down the list. 0, 2, 4, 6, 8, and 10. What pattern do you notice about each of the shaded rows? Well, they're all even numbers. The products all end in 0, 2, 4, 6, or 8. Complete the rows for 2 and 4. Oh, I'm sorry. Compare the rows for 2 and 4. What do you notice about the products? All right, 2. Okay, so 4. From 2 to 4, there's 0 is the same. 2 and 4, 4 and 8, 6 and 12, 8 and 16, 10 and 20, 12 and 24, 14 and 28, 16 and 32, 18 and 36, and 20 and 40. So what is the pattern that you notice about those? I noticed that the products for 4 are doubled the products for 2. Shade the columns for 1, 3, 5, 7, and 9 blue. The columns. So the columns. For 1, 3, 5, 7, 9. Okay. What do you notice about the products for each shaded column? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 3, 3, 6, 9, 12, 15, 18. I think all of the products in. But let's see. Odd, even, odd, even, odd, even, even, odd, even, odd, even, odd. So they're repeating. Compare the products for the green square. What do you notice? What do you notice about the factors? Okay, so the green ones are basically where the blue and the yellow overlapped. So they want us to compare every other one of these squares. So if I just look at the 1 and the 3, I notice that the column for 1 and 3, the green squares coincide with the even factors of the rows. And the answers are all even on the greens. Okay, the products are all even. One factor is odd, the other factor is even. So now I just want you to look at the table and see if you can notice another pattern. You could say, like, the row for 1, it's counting up by 1 each time. The 4s is kind of interesting. We go 0, 4, 8, 12, 16. And then the 1's digit again goes 0, 4, 8, 2, 6. And then it's going to repeat again. So in the row for 4, the pattern for 1's digit repeats 0, 4, 8, 2, 6, and so on. Use the table to write the products for the row for 2. Okay, so we look for the row for 2, and we notice that it's 0, 2, 4, 6, 8, so on. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Describe a pattern you see. So in this one, the 1's digit repeats. In a 0, 2. So 0, 2, 4, 6, 8, 0, and we just keep going like that on and on. So that 1's digit repeats 0, 2, 4, 6, 8. Is the product even or odd? Write even or odd. So odd times even. So 5 is odd, 8 is even, and when they meet, I get an even answer. 6 is even, 3 is odd, 6 and 3, and where they meet, I get even. 3 and 5, and where they meet, I get an odd. So odd and odd gives me an odd product. 4 and 4 gives me an even. So basically, we should notice a pattern that anytime you multiply odd and even, your product will be even. Whenever you multiply even and uneven, your product will be even. If you multiply two odd numbers together, you'll get an odd product. All right, use the multiplication table and describe a pattern you see in the column for 10. So if you look at the column for 10, I notice it goes 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All the ones digits are 0. Okay, how about in the column for 8? 0, 8, 16. Let's see. 0, 8, 6, 4, 2. Then it goes 0, 8, 6, 4, 2, 0. So I just made a list of the ones digits in the column for 8, and I noticed there it goes 0, 8, 6, 4, 2, and then it repeated 0, 8, 6, 4, 2. So the ones digit repeats the pattern 0, 8, 6, 4, 2. Okay, is the product even or odd? Even times even has to give us an even answer. Odd times odd has to be an odd product. An odd and an even has to be an even answer. Even times odd, we just did that one, has to be even. Use the multiplication table, rewrite the pattern correctly. All right, so let's see. 6, 12, 18, 22? No, 24. So it should be 6, 12, 18, 24, 30, 36. Okay. So the 22 was wrong. Complete the table and describe a pattern you see in the products. All right, 5 times 2, 10. 5 times 4, 20. 5 times 6, 30. 5 times 8, 40. 5 times 10, 50. Okay, so what pattern do you notice in the products for those problems? 10, 20, 30, 40, 50. The ones digit was always 0 when multiplying 5 by an even number. All right, 14. 5 times 1, 5. 5 times 3, 15. 5 times 5, 25. 5 times 7, 35. 5 times 9, 45. Okay, this time I noticed that, sorry about that. All right. Sorry about that. Computer decided it wanted to take over again. All right. So here I noticed 5 times 1 ends in 5. 5 times 3, the 1 digit's 5. 5 times 5, the 1 digit's 5. So right? So this time, 5 was multiplied by an odd number, and the product always ended in a 5. Explain how patterns of the ones digits in the products relates to the factors in 13 and 14. If the factor is odd, the product ended in 5. If the factor is even, the product ended in 0. All right. Helene selected an odd number to multiply by the factors in this table. Write even or odd to describe each product. So it doesn't matter what the odd number is. So here we can say that this is odd, even, odd, even, odd. An odd number times an odd number will give me an odd product. Odd times even will give me even. Odd times odd, odd. Odd times even, even. Odd times odd will give me an odd answer. Okay. All right. And the last one for this lesson today. Whose statement makes sense? Whose statement is nonsense? Explain your reasoning. So on the left, it says the product of an odd number and an even number is even. So he's saying 3 times 4 equals 12, which is an even number. The product of an odd number and an even number is even. I can circle 2 equal groups of 6 with no tiles left over, so the product is even. All right. Giselle says 2 times 6 equals 12, and she says the product of 2 even numbers is even. So the statements both make sense. So they're both correct. 3 times 4 does give me 12, which is an even number. And remember that 3 times 2, which is 6, is the same as doubling. So 3 times 4 is the same as saying 3 times 2 doubled. And that's what Gunter's done. Giselle's work, she just said 2 times 6. She has 6 groups of 2. And there aren't anything left over, so yes, they're both even numbers. Write a statement about the product of 2 odd numbers. Give an example to show why your statement is true. Write a statement about the product of 2 odd numbers. Okay, so the product of two odd numbers is odd. Give an example to show why your statement is true. So if I say I don't know, something like 3 times 3. Okay, so how can we show that that's true? So 3 sets of 3 so let's put 9. We have 3 rows of 3. And if I put them into 2 equal groups, I'd have a group of 4 and a group of 4, but I have 1 tile left over, so that makes it odd. All right, so you'll now do your online practice for lesson 4.7. If you need help, use your textbook for the explanations and also use your video. You can also stop and ask me for assistance if needed. Our next lesson tomorrow will be multiplying with 8.